This video will demonstrate how to use the TriStar MPPT Setup Wizard and includes an example walkthrough. Here I have the MSView software program open. This is a free download from Morningstar. You can actually use the MSView Setup Wizard tool before you even buy a product, so you can run through your settings and see if you get the settings that you want. The tools here have all the different setup wizards available for all these different products, and we're going to use the TriStar MPPT Setup Wizard. And the first thing that comes up is a warning, a little caution that you don't want to create any settings that would result in damage to your equipment. And then you also want to know that your dip switches can only be changed when the controller is off. So you want to turn off the controller and change the dip switches and then turn it back on. If you change dip switches, it will go into a fault and shut down, but then you can just turn it off and on, and dip switches will be in effect. Now, if you just wanted to check it out, you downloaded the program and you want to just get started, you can just do create new and just get started running through and seeing how to use the setup wizard right away. Or if you have a device connected like I do, I'll go in here and connect to one of our TriStar MPPT 60s. And it makes a connection automatically. You can get into the setup wizard by right-clicking on the product here and then opening up the setup wizard. Now we want to read the settings that are already on there, so you can go in there and read them. So this would load the settings here into the setup wizard. So go through and do the read from TriStar command. And this is the controller we're connected to, and it's connecting, read configurations, and it read successfully. And here are all the settings that it's currently programmed with. So you can review all the settings at any time. You can review your custom settings and make any changes you need to. Start with the regulation, that's the absorption voltage, compensation, and it goes through every setting, including the LED settings, and then communication settings, and the notifications, and then the daily log settings. So this gives you an idea of what settings you have right in a quick view. And then it automatically shows you the 24 volt and 48 volt adjustments if you have it set for that voltage. From here, we may decide, well, I don't like this, I want to change it. So you can go into edit. And then this is the same as running a create new. So whether you go into create new or edit, you're going to have this same menu and choices of programming options to go through. This video does not include wind charging control setup information. If we do not currently have the wind charging control information in our manual or a white paper regarding this feature, please contact Morningstar Tech Support if you are interested in using the wind feature. So let's get started with the custom settings for solar charge control. You select the solar charge control and then selecting next, that brings you to the absorption settings. This is where you configure the appropriate absorption voltage and time and the temperature compensation, and then finally battery service reminders if needed. So the absorption voltage is the voltage where the battery should come to a full state of charge. For lead acid batteries, the absorption voltage ranges from 14 volts shown here for gel batteries up to about 15 volts for L16 type batteries. These are flooded lead acid batteries. So you want to make sure you check the manufacturer specs to make sure it corresponds to what you want. In this case, what we have here, we're in edit mode, so we've already taken the information from the controller. We have that here, and you may only need to make one or two changes for your settings. In this case, we might want to be bumping up the time because it's winter and the battery manufacturer suggests that you may want to set it for longer periods of time during the winter. So I'm going to just set it to 3 hours here. And so this would be like a winter setting.
so you get a little bit more longer charging, so because you might be in a lower state of charge more often. And then this absorption extension, you can enable that or disable that. And usually you just want to keep it where it's at, usually 30 minutes. You can look at the chart in our manual, but I'm going to bump that up to 40 minutes because if it's getting to a low state of charge, we want to bump it up and extend that longer during the winter. And you can decide here, battery temperature compensation. This is going to be good for lead acid, the minus 30 degrees Celsius. Now, if you're programming other types of batteries like lithium ion, you may want to set it to 0 because it doesn't need temperature compensation. However, in our case, we have lead acid, so that would be minus 30 millivolts, which is 0.03 volts per degree Celsius, which is for a 12 volt battery. And notice that all these settings are in 12 volts. And then you'll see it there in the chart at the end in 12, 24, 48 volt settings. So you can review the voltage that you're interested in. And there may be some types of batteries that need lower settings or higher settings. In addition, if you're doing 36 volts, you need to use the same ratio as you do for the voltage. So if you're doing 9 volts for a 36 volt battery, you would also use the 3/4 volt factor as you would use with the voltage with the temperature compensation. So instead of 30 millivolts per degree Celsius, you would be down to like 22 or 23 millivolts per degree Celsius. And you can set the maximum and minimum temperatures. There's a little bit of information on the battery information page that we have on using the temperature compensation as sort of a switch to disable charging. So for this application, temperature compensation settings can really be useful also. That's all the information on the absorption setup screen. The main three things to think about is the absorption voltage, or sometimes referred to as bulk charge voltage or regulation voltage. There's also the absorption time. That's the time that you want it to regulate and bring your batteries to a full state of charge. And then the absorption extension, if the batteries get below a certain voltage, you want to extend the time that you keep them in absorption, and then the battery temperature compensation. So moving on to the next screen, the float settings. Our settings may be a little bit higher, but for solar, that shouldn't be a problem because you're not going to be holding it at this voltage except during the daytime. It's not going to stay and float for months on end. However, in some cases, it may make sense to make it a little lower if the batteries are not cycling very much at all. Or during the summer, you also find that you may not want it to be as high because it's going to be longer days, going to be spending more time in float. So it may not need it as much in the summer. However, in this example, we're looking at setting it for the winter. So I've heard of some battery manufacturers suggesting higher settings for the winter. The additional strain on the batteries can justify this in the shorter days, so you don't really have to worry about it extended periods of it being in float, and it gives you a little bit extra charge if it needs it. So 13.8 should be fine, and this is the kind of settings that you can adjust if you find them useful. I mean, generally our settings should be pretty good. And if you need to bump them up or lower them a little bit, you're free to do that however you wish. So we're also going to set the float timeout a little shorter because these are shorter days, and we don't want it to get to the end of the day and you're not at full state of charge. So the float timeout is a cumulative number of minutes that the controller is not afloat. And also notice here that the enable float can be canceled, so you don't have to have float. There's some batteries that don't require it. Lithium batteries can stay in an absorption state all the time. In this state, it never really comes out of absorption into float on a daily basis. So these settings really don't matter if you don't have your enable float, so your timing doesn't matter because it never really goes into float. It will just stay in absorption. And the enable float cancel is for when the batteries get discharged beyond the usual amount. So this setting is lower than you had for the enable absorption extension. This is when they get partially discharged, and this is when they get more significantly discharged, and you want to go through a full day of recovery the day after a very low state of charge. This may not be necessary, so you can enable it or disable it. Some types of batteries may not need this time, so something to consider. So going to the Equalize charge settings, you can enable Equalize or disable Equalize. Generally, with gel or sealed, you wouldn't have Equalize, but if you need Equalize for flooded, you can set that. You can set the amount of time for the equalization charge. And then the auto equalization interval sets the number of days between equalization charges, the size of your system, the average depth of discharge, and other factors may determine how often you want to set the equalization charging for. And just a reminder that dip switch 7 enables this auto equalize feature. And then the Equalized Timeout, which sets the maximum length of time that will be in the equalization stage. And this is for when the battery has completed the absorption. The time is spent above the absorption set point voltage. And this is to prevent partial equalizations for extended periods of time. And then we have the high voltage disconnect settings, which will disconnect the controller and discontinue charging if the battery is above the equalization voltage or maximum voltage. So this might be situations where you have other charging sources in the system or other controllers possibly set to higher voltages. This will disable the charging until the voltage comes back down to a more moderate level. As you can see here, this is set higher than the equalization, so this should be set higher than your maximum voltage that you expect to see on the system. And this is also temperature compensated, so always stay above the equalization voltage. This will protect the batteries from being overcharged and give it a break from charging if the voltage has gotten too high. So moving on to the next screen. So this is a equalized timeout. This is kind of a warning to indicate that your timeout has to be longer than your equalized time, which makes sense, because you don't want it to time out before the equalized time is done. But I forgot that we weren't going to enable equalize. So this is the kind of thing you can do by mistake, and then if you enable equalize and someone manually does equalize somehow, that could be a problem if you enable something that you don't want to. So when you do this custom setting, it's important that you make sure you get everything right, or else there could be problems. So moving on to the next screen, we have the charge mode and limits. The first thing that you find here is the enable maximum regulation limit. This is different than the high voltage disconnect. This setting creates a maximum charging voltage regardless of what the temperature is. It will not regulate the voltage above this level. This will protect voltage sensitive loads and override the other regulation settings, so if it gets very cold, it will not exceed 15 volts no matter what. And then the next setting is the enable battery current limit. And this is set if you want to limit the current. This reduces the max charge current of the controller, which may be required to limit it below the max charge rating of the battery. So that's a nice feature, especially for smaller batteries. But typically that's not really necessary. In our case, we're not going to use that or this fixed array voltage target. This allows you to pick a fixed input voltage or a percentage of the open circuit voltage. This might be useful for hydro or power supply, but for solar application, the MPPT sweeping should be perfectly fine. And here are the LED transition voltages. I would say for lead acid, these settings are pretty good, and during charging this may not be so accurate, but during discharging these voltage transitions will make a lot more sense. So when the battery is discharging, you'll start seeing these voltages on the discharge, maybe not on the charging, because you'll quickly rise the voltage above these levels during charging. So this would be more of something to look at when your batteries are discharging, and when you're more concerned really is when the batteries are discharging the state of charge. More so than when it's charging, you're less concerned about a low voltage disconnect or something. And if you're programmed for a different voltage like 36 volts, you would want to adjust these settings accordingly so that it corresponds to the voltages for a 36 volt battery. So 9 volt nominal if you're charging for 48 volts, and then other types of batteries might be a little higher or a little lower, so something to consider possibly, but for lead acid you should be fine with these settings. So going on to the next screen, I just want to mention that up until this point, all the settings can only be enabled with switches 4, 5, and 6 up. At this point, any settings that you make will be enabled whether you have 4, 5, and 6 on or not. So starting with the logging screen here, these settings will be enabled regardless of what the dip switches are. The TriStar MPPT includes a data logging feature which will log data internally in the memory. You have variables that are always logged, and then you have optional variables. If you only log the standard values, you can get up to 200 days of daily log data. Now you can add additional variables, as you can see here. But for every variable you add, it will reduce the maximum number of days of data logging. So for every optional variable you add, you reduce the number of days of data logging, but you get more information every day. So it's a matter of whether you want more information or more days of data logging. So the maximum daily array voltage may be important to you. You may be concerned about that. The maximum daily power output, that's a nice one. You get to see what the maximum power, I'm going to check that one off. And then the daily amp hours, which is really nice to know, or the watt hours. But with this battery, I'm just really concerned about amp hours. And then the minimum and maximum daily battery temperature is another nice thing to know. So you know what your battery temperature is, and if you're regulating to that voltage, and you can kind of check it and say, hey, well, why is my voltage so high or so low? You can look at the daily battery temperature and tell what it should be based on the temperature compensation. This final one I would recommend always using, because this is very good information about whether you're going into float, whether you're going into absorption. This will tell you the number of minutes per day that you're in any of these states. You'll know if you've made it through an equalize, you know how long you spent in absorption, and you can look back at your daily float and absorption information. You can see this on LiveView or the TriStar meter, or you can download it to an Excel file. So this is a really good thing, so you know the health of your battery, if you know your battery's getting charged, if it's never going to float or not reaching that many minutes of absorption on a daily basis. You may need to increase the size of the array, or if it's just going into float every day, no matter what the weather is like, you know you've kind of oversized the array possibly. Just gives you a good idea about how you size the system, I would say, and you can start doing something to adjust either the battery size or the array size. Typically the array might be modified with this information to make sure that you're getting a full state of charge on a daily basis. And then the communication settings, the meter bus address, which you'll need if you're using a meter hub, and then the mod bus address when you have multiple devices you need to network to, and the controller name. You can give different controllers different names. Then you can set up the IP address, whether it's going to be static or whether it's going to be DHCP, where the router automatically assigns the controller an IP address. And then the ports. We'll go into more details about the communication settings in other videos. Again, these are settings which will not depend on dip switch settings other than the IP settings, dip switch 8, which enables you to program the controller with the Ethernet connection. So in that sense, yes, it will be affected whether you can actually do anything other than monitor using Ethernet. And then going on to the notifications. So the rest of the programming is more communication settings, setting up SMTP email notifications and SNMP traps. So this is something we'll cover in another video at some point, but there is information in the communications document. But for now, we're just going to skip through the notifications and finish the custom settings. And here we are back on the custom settings summary screen. You can review the settings and see the settings that were edited. As you can see, we changed the absorption time to 3 hours, absorption extension time to 40 minutes, and going down, it's a 24 volt battery or the 48 volt or 12, whatever nominal voltage you're interested in. And coming down, we didn't really change that much else, but I guess here we added a few logged values here, the true indications here. If you see anything that you want to change, you can go in and edit it again using the edit function. And but we're not going to do that now because we have everything we want. And then if you want to save your settings for later use, you can use the write to file command right here, the write to file button, and save it as a file on your PC. Here we have it saved here. I'll just save it again. And that's a simple thing to do. This is great if you want to offer this to end users. You can pre-program it with presets. You can program, if you're a dealer and you want to offer this custom setting to end users as an added value, it's a very simple process to create a custom setting and have a preset for the particular system or battery that you want to sell. And this file can also be useful with our tech support cases. And another option is printing the set point summary page using the print command. And we get printed set point summary pages sometimes in our tech support cases as well. And then the read from file, we'll just read from the file we just created, but that is not going to change anything since it's the same file basically. And that's useful not only for editing certain custom configurations, you can go in and edit from here, but also if you want to use the settings with multiple controllers, which I mentioned, especially for dealers, we'll be able to offer a preset, basically a plug and play option for a particular application. I also wanted to mention the help button here. This is on all the screens actually, and it will show you the help topics. So this tells you basically all the information for each screen if it's available. And this is the same as what's in the help topics in the main menu here. So you see all the information about this particular screen and custom set point summary information. And it also has a nice little note here saying that dip switches 4, 5, and 6 must be on to enable the custom charge set points. And sometimes this gets really long. In that case, you can move this up the screen and it will show it at a higher point on your screen if you don't get the full help topic in there. So let's go ahead and program the controller now. Using the program button, since we're connected here, this will disconnect and program the controller. And the communications information pops up. That's mostly if you are not already connected to it and didn't enter it from the controller itself. It would have to determine, you would put in the bus address if that's needed, and the COM port. And it just takes a couple seconds here, and you're finished. And that indicates that the controller was programmed successfully, and you can push finish. And now we'll close out of this, and we'll connect again. So we're connected again. Now let's look at the state. And you'll notice that there's a fault here. Charge state fault. And it says custom settings edit fault. So that means you've done a custom setting and you really can't start the controller again. Basically, you need to reset the controller. You can either disconnect it, either power it down or repower, or do a reset. So let's see what happens if we go into the properties here and use the control coils and do a reset control. Now this error message, you can ignore that. This will come up, and we did do a reset of the control, and cancel out of this, and looking at it again, now we're back on, no faults, and that reset the controller. But when you get that error message when you do a reset, you can pretty much ignore it. And one of the ways you can check if you've got the right settings is your target regulation voltage, but in my case I don't have the dip switches set on this actual controller, so this will not be relevant. But if you were to look at the temperature, battery temperature, and the target regulation voltage, you could tell the target is in MPPT, the target should be the absorption voltage that it was programmed with. Thank you very much for watching this video, and I hope you found it useful. The setup wizards for other controllers are similar to this, but there will be differences. Here are a list of links that are related to the TriStar MPPT Setup Wizard. If you get a chance to watch the first 2 videos in the Setup Wizard series, I suggest that would be a great place to get more information, as well as these documents.